Hello. What's up, Coop? How come Perseverance was able to use a parachute? Isn't the atmosphere on Mars super gimpy? Yeah. You basically, you have to use like a really strong material that's also really light, I guess. But it also has to be huge to trap all the air, because it's not very dense at all. I'll get paint out. What's good, pal? What you snacking? I had a bit of a pizza there, to be honest. Been on the mozzarella and tomato pizza buds recently. What am I doing? Pencil? Yeah, some of this. Okay, so we're gonna say red. Yeah, okay, red's gonna be like the individual molecules of air, I guess. And on Mars, yeah, it's like they're like super. Oh, that's really light actually. I'll make it bigger. This one. That's better. It's not that dense, so there's low pressure, and that means there's nothing keeping these little molecules together. So in like a really big volume, you only get a small amount of mass of the individual molecules. But then on Earth, there's way more of them. So that'll be like Mars, let's say. But then on Earth, because there's more pressure, there's gonna be more molecules in there. So they get like really packed together. Fucking everywhere, right? So this is Earth, but then back in the Mars situation where they're kind of, there's less molecules. You need a way to trap as much of this as possible. So this balloon has to be huge so that the mass of the gas is relevant, I guess. And then because the balloon's so big, the material has to be quite strong, and also quite light. Because if you have a huge balloon and you have a really heavy balloon envelope, then that's going to be more weight that you have to lift up. So you want to try and keep that to a minimum. So when they use parachutes in Mars, they're like really fucking big, and they're like very lightweight and strong. I think that makes sense. I don't know. Let me get my glasses in a sec. Magic space parachute. Yeah, I mean, basically, right? I don't know. It is kind of magic, I think. Before we get started, actually, I'm just gonna show you another thing about the parachute. You might have seen there was like a specific pattern on the parachute. It was actually kind of cool. Let's go space.com. On stream, yeah, it is. So yeah, this is the parachute, and the design is kind of weird, right? I mean, why not just have like one color or something? But the reason why is because we actually don't know anything about how. Well, we know a little bit, but we don't know enough about how to properly deploy in Mars with the parachute. So you have cameras on the rover which look up at the parachute and sees this pattern, and then based on what happens to the parachute, like let's say some parts will start to crease in, maybe like this part is like fully deployed after this part, because you have different pattern going on around the whole thing. It's easy. And if that happens, then you're completely lost because you don't know how much it's rotated by. But then you might ask, oh, how do you get like a perfectly random pattern. They didn't do a perfectly random one. They just basically this kind of, if you convert this to binary or something, it like says "Dare mighty things." And I don't know exactly what's going on, but I think basically like, maybe like the reds are like a 1, and then the whites are a 0 or something. I actually don't know. But somehow you can convert this pattern into binary, and you can get it to say "Dare mighty things." I think that's pretty cool. It's very NASA, like just getting like fake woke shit in their parachute, you know? Very NASA. So yeah, that's the story of parachutes, I guess. Guess I'll do a bit of work. I took a break yesterday because I have an assignment during the weekend and I need to get that shit done. But we've got so much work done so far that it's okay to take a break now and then. I'm really happy with the progress. So it's all good. Alright, I'm just gonna get chat on my phone. Hold on a sec. Alright, we're good. Alright, what's on the agenda today? I guess let's just get the screen. Take it off first. What did I get to the last day? I think I stopped in the middle of a paper? Yeah, I did. So let's go back to this one. I like stopping in the middle of a paper, because then when you start the next day, you can just get right into it as opposed to like figuring out what to get started with. So I don't know how far into this I got. Let's see what my notes say. Transgender pride. I wouldn't have known what that is unless I moused over it. What's up, man? You well? Okay, blah 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 blah. I think I might have blitzed through this quickly, actually. Because yeah, I noticed a lot of these papers, they kind of deal with like the rock formation and like the geography, the geology a bit too much, as opposed to like just what's interesting about the area. And I guess that's the answer, right? The geology is kind of interesting, but it's just so boring to read about. I don't like geology. I do like geology, but I'm not too interested in reading about it right now, I guess. It's kind of weird reading about like the areas on a different planet, because it's sort of like you're reading like a book or something and you're learning about the fucking Shire for the first time or something. Like the Nilo Syrtis region, defined as the highlands region north of the Syrtis Major volcanic complex. It's kind of sick. I'm mostly just looking for anything to do with methane in Nili Fossae. That's all I want to learn about, and I can't find anything about it, so I'm. Could I get a labeled glove of Mars? I think you can get stuff like that. Yeah, I mean, this isn't probably very labeled, but like, look at this. You can see some marks there. I can show you like a map of Mars. Images. High resolution for Joel. This one looks kind of cool. Let's check this out. So this is basically a labeled glove of Mars. It's pretty mad, isn't it? I think we're over here somewhere. Like that's where my project is focused. Perseverance. Okay, I blitzed this the last time. I didn't guess this quite well. I think it might be up here somewhere. Jezero crater. I can't see it. Maybe Jezero crater. It might show on the map where it is. Oh yeah, see this one? Yeah, this one here. So you can see Perseverance is like here. So let's go back to this map. Somewhere around here, is it? There should be some crater somewhere. Jezero. Yeah, let's see, where is Nili Fossae exactly? Maybe in images here. Hargraves crater. I mean, surely I can just check up the long and lat. 22 north, 75 east. Should be like around here somewhere, I think. Let's see if we can see it. Who would have known that reading a map would be so fucking difficult, right? Actually can't see it. So we're either looking for Jezero crater, which is where Perseverance landed, or else we're looking for Nili Fossae. And I thought it would be around here. Maybe it's a little bit up. Certus Major Planum. Yeah, I don't know. I can't see it. Let's go back to this one for a second. And this is saying Perseverance is here. Maybe I'm getting confused because of the bulge of the map or something. Yeah, I just can't see it. Yeah, we're somewhere in this region for sure. Maybe they don't have it labeled on the map. I find that hard to believe. Maybe it's a Nili Fossae map. Is this what I'm looking for? Oh, Certus Major. We saw that, right? Certus Major. Oh, they're quite close. Look how close they are. Jezero crater is here, and Nili Fossae is here. They're super, super close. Okay. Okay, we're getting to the bottom of this. Certus Major, which is here. Ooh, is this... Oh. Oh, boys, we're getting close. We're getting really close. Hey! Here we are. Right here, right here. Nili Fossae. Okay, so... And what? Jezero crater is just to the south? Let's go back one more time. Nili Fossae is up here, and Jezero is basically directly south at the northwest of... Is this planet Asia? Is this planet Asia? Alright, let's see. So yeah, Jezero crater should be like here, right? They don't have Jezero crater put it down. Interesting. Yeah, it should be like right here. But this is the place we're checking out. And for what I've seen so far, is this what does Planitia mean? Let's look up Planitia meaning. A low plane, okay. So this low plane, this was made from a meteorite, I think. I think like something crashed, and it just made this big fuck off like dent in the planet, let's say. But the impact kind of had a trickle-on effect over here, and it was like a fault line where this like little valley was created basically. So the impact here created a valley here, and that's what Nili Fossae is. It's like a big long valley, and that's the place we're checking out at the moment. That's where we think the hot air balloon will be fucking around basically. So yeah, it's kind of sick seeing a map, isn't it? Now I know where it is exactly. So I wasn't too sure before. So let's see. Yeah, right here. I can see it clear as day. Alright, perfect. Okay, so what are we gonna do? I want to get a bit more of a clearer picture about Nili Fossae still. I haven't answered the question, which was why are we choosing this place? Let's see what my goals were. Okay, so this question, can you see this on stream? Yeah, you can. Like, yeah, it's interesting because of the rock formation, the rocks and all that. But that's not cool for us. Like, I want to know why a balloon should go there. This can be done pretty easily. This has not been done yet, and this ties into the first one too as to why I want to get it done. And then the distances between past landing sites and Nili Fossae. Well, we just learned there that it's pretty close to Jezero, which is where Perseverance landed. That's pretty cool. And as I said here, it ties in with sample return mission. That's also pretty important. So, like, we kind of have number 2. We have the tools to get number 2. And number 4. But they're not interesting to me at the moment. I want to answer 1 and 2. So let's look into it. So like fucking Nili Fossae methane. Let's see what happens. Alright, mysteries in Nili Fossae. Search for methane gas. Okay. Okay, we have a fuckload of papers to go through. And a few of them seem to be from the 10s, which is nice. I don't like reading really old papers. So that's good shit. Okay. So let's get to the notes. Make a new day. It's a new life. It's a new day. View, add some lines, back it up. We go Nili Fossae 2. And we'll hit them up with the goals again. I mean, I said there pretty much. Methane and Nili Fossae. I want to get this done today. I don't like this is not something that should take longer than today. Because it's only going to be a small part anyway. So I don't want to spend too long on this. Yo, what are the sound levels like, guys? Is the music okay? Like, with my voice and shit, you can hear my voice and you can hear the music okay? That's all I want. Like, fuck, let's not make too many goals. Keep it simple. Alright, so let's roll. Dope, thank you, thank you. Okay, so we have an article. Mysteries in Nili Fossae. What's the name of the discipline that involves the study of planetary environments? Maybe like a bit of astrobiology, astrochemistry, maybe. I don't know what the exact name of it would be. Oh, good, creep. Thank you, thank you. Yeah, I don't know, man. I think there's a lot of astrobiology coming into that. Astrochemistry, I guess. Yeah. Alright, let's check it out. New images, high resolution camera. What year is this? 2015, okay. Northeast of the volcanic region Syrtis Major. So I'm gonna make a little note here. Volcanic activity, maybe reason for methane levels being a bit high. Question mark, question mark. Alright. Ravens are blocks of land that have fallen between parallel faults, sometimes forming grit valleys. So that's what I was saying. So like, Nili Fossae is a big graben apparently, but it's just a fucking valley. Like, let's keep it a buck. Most likely associated with the formation of it. It's just, yeah, that's what I was saying earlier on. What's next? What of orbit is shown? A fascinating mineral diversity. A planetary scientist is another thing you could say for someone who studies the environments of other planets. TBH. Philocicillate. I'm always butchering the pronunciation of a lot of these words. It's so funny. Phyllosilicates, yeah, which are clays. And you also got some carbonates going on, and you also got some opaline silica. Shit. Here we go. Develop when groundwater removes material from underneath the surface. This gradually relocates the spring line further upstream and carves a valley in the process. Okay, makes sense, makes sense. Image also contains evidence for percolating hydrothermal fluids. Okay. Again, like it says that there could be methane there, but it doesn't say anything else about it. So I guess a secondary goal, like why? It seems like it's always on the short list for like potentially a place that a rover can go to, but why is it never making the final push to be like the guy, you know? That's what I don't like. Okay, next paper. The search for methane gas emission features in Nili Fossae, Searches Major, and Is This Planitia Mars? Goro Komatsu, Gian Gabriel Ori, and Marco Cardinal. And their friends. This is one of those presentations where they don't have any words. They just kind of put up the pictures and say stuff, which is how you're supposed to do a presentation, but it's not good when you're reading over it later on. Okay. Okay, but it's giving me a lot of stuff with the methane at least. So this is a presentation, I'm gonna say. Bracket it up. Oh, and I say who it's by. I'm just gonna say Goro. Alright, what's going on here? I need to change that to summer. Just gonna leave that little note there for something to do maybe down the line a bit. Okay, so people have already modeled this 08 or 09, it's saying. So I'm just gonna put this reference in there. So Geminale 08 and Mama 09. Mama also showed a geographical restriction. I showed him plumes at specific locations. These are going to be really good papers to look at for sure. So methane mission on Mars is still an unsolved question. What am I trying to say? What am I trying to say? This is like that valley talking about. Read this paper last week and I was super hyped for it, but it ended up being kind of boring. But maybe I should check it out again because it's always mentioned when Nili Fossae comes up. Lions 05 and O's and Sharma 05. Bobby Shmurda, pretty fucking lit, right? Yo, Bobby Shmurda throws the hat in the air and you never see it come down. Where's it gone? Where's it gone, huh? I don't even know what he did, to be honest. He's probably a bad man, but fuck me. I'm looking forward to some new Bobby music for sure. What you think? Surely it's like one of the most, like, for someone to release like one song, maybe two, I don't know how many songs released, and then to like kind of fade out of existence because he was in jail for so long. Like how many other people can come out of jail and still be like that hype after what, like 6 years, is it? Did that come out in 2014? I actually have no clue. But I think it's pretty impressive, like, to be fair. Okay, that's this presentation done. What am I looking at here? Small thing. Yeah. Few references. Elman coming up again, and our boy Mama, which I noted down already. Yeah. The boy can make music. Facts. All right, let's look at it. Bum bum bum. And this is by Eric Hand. Did you see 7 years prison? Fuck me. He had a verse though when he was in prison, right? Didn't he? He was like featured on a 6ix9ine song, I think. He was like on the phone, and then they recorded the phone call or whatever. All right. Oh, 09 as well. Pretty lit. These papers were both very recent when this guy made his paper. And yeah, here, don't worry about asking off topic shit. I'm always down to talk about fucking hip hop anyway, you know that. I wish I could play whatever music I wanted to. I would be absolutely banging here, like. Forming water, something like that. Okay, so I think this is looking to like summarize the papers a little bit. That's true. Like I'm liking just like the beats and shit. But like I have so many like random beat tapes I listen to normally, like when it's like playing a game of chess or something. Like fucking Jay Dilla, else like MF Doom's beat tapes and stuff. But like they're all copyright, I think. So I don't know if I can listen to them even though there's no lyrics. I have to look into it. Yeah, you're right. Like if I listen to lyrics right now, my mind would be probably fucking a little bit more distracted, you know? For sure. Finding evidence for a mineral that could tie all these observations together. Ellman used a spectrometer on MRO to identify two small outcrops of a material called serpentine. Serpentine arises from another mineral called olivine in a hydrothermal process in which hydrogen gas is produced, a potential energy source for microbes that could in turn produce methane. Dun dun dun! Life on Mars, boys. Here we go. Discusses Ellman's paper. Oh, Ellman was just some fucking PhD student. Fair play. You love to see it. Yeah, man. Fact. I mean, it's not even like it's not even a case of like, you know, if you're on the bus and you don't pay for it or something, or you're on the Lewis, you don't pay for it, and you like if you get caught, you're kind of fucked. Like they have like listening algorithms that can check this shit. So like imagine instead whenever you went on the Lewis, it like scanned your phone or it scanned like your pockets to see if there was like a ticket or if your phone had like tapped on, and then based on that information it kicked you in or whatever, you know. So I think what happens is you listen to it, you get a warning, and then you just do it again, you're kind of fucked. But it's always nice to have that warning in the back pocket, because like if you're ever watching a video and you're not too sure, you'll get the warning then and you can chill. But yeah, it's a bit mad. I'm digging this playlist, to be honest. How's the apartment search going? Yeah, not bad. I haven't got too caught up with like packing up and shit yet, as you can see that everything's clear. But like yeah, all like in terms of like guarantors, making sure that we're okay to move in and all that, like it's all on the cards. It is gonna be a bit of a tussle moving everything over, but I think we're just gonna like rent a van or something, or like there's some like moving services stuff you can do too. So whatever is cheaper, I wouldn't mind fucking going for a spin, to be honest. Like get behind the wheel again, you know. So we'll see how that goes. We will see how that goes. What are you up to at the moment, man? You just chilling? How's work and shit going? You all. Yeah, I mean, that'll be if we go down the truck buzz. We'll have to see how much we can fit in, you know. We have like tables and shit, desks. I don't know if like just renting a normal car will work for that, you know. Whew. Nice, man. I'm happy you're happy. Do you still have to work in a suit and stuff, actually? Nice, nice. Yeah, today was a good day too here. I went out for a walk earlier in just my t-shirt, so I was standing out. Final stretch in the evenings, huh? The process of serpentization also produces methane itself without the need for life. That's a weird one. I wonder. Okay, so it's saying that the result of serpentization is something that can feed microbes, and then those microbes can also produce methane. But it's also saying that the process itself produces methane. So, like, whether there's life there or not doesn't fucking matter. Check this.
This the remix to Bobby Bitch. It's murder, bitch. Nah, it's murder, bro, bitch. Bro, Bobby Bitch is like 7 years old, bro. You gotta grab something new, grab something fresh. That's not gonna hit, bro. You said that's not gonna hit. What if we throw Waka on that? He gonna grab the youth. That's gonna hit. Waka Flocka? If you don't like him, Rich Homie Quan. Why y'all looking like? Okay. Hey, Waka, you doing that? Murder, baby. Bro. It's a new time, bro. They don't even make music like that no more. Original. You know
I love all the lads in the room just chilling.
Just me on that end, probably. Yeah, that'd be nice. Okay, throwing it hot.
Holla at me.
Bobby. This is older than Bobby Bitch, bro. Something brand new, something fresh, something. that was gonna be hotter, nigga. That's not hot, nigga. It's hotter, nigga. No remixes.
That's nice. Like, fuck. If you have to wear a suit all the time, that'd be a nix. This sounds like some grime stuff. I could see like Stormzy on this, no?
It's murder, bitch. It's murder, bitch. All my niggas know it's murder, bitch. We got the murder shit.
The boys are honest god.
It's murder, bitch. All my niggas know it's murder, bitch.
Interesting balloon you got there. Hey, we're all about the balloons here as well. You gotta chill out now and then, huh? Okay. Where was I with the notes? Also produces media itself, but yeah, okay. Oh, it's like here. Hey, Max, my man, thank you so much. I appreciate it. I think that might have put us over the 50 mark. Pretty dope. On the way to the top, boys. We'd love to see it. Okay. Yeah, man. Of course. It's a cute animation, isn't it? It's kind of fun. I need to change the noise for it though. Like the noise is just a stock standard noise, but I think we can get a bit creative. Okay, so one idea I have here is, can you figure out how much methane the process should generate, I guess, is that a word you could use? And then see the difference. If it is less than expected, maybe life is there. Okay. It's certainly an intriguing coincidence that one of the major regions in which we find these minerals has been highlighted as a possible source region of methane. But there's this timing problem. The problem of timing arises because serpentine of Mars is ancient, about 3.8 billion years old, whereas the reports of methane gas are contemporary, yet it is possible. Element says that fractures deep underground could be providing the necessary water and heat for serpentine to be formed today, and for methane to percolate up. Okay. Yeah, no worries, man. I probably need to get in that shit too myself. But we move. Catch you later, man. Best of luck. Discrepancy between how do I say this? I could just say what they said, because they said it quite well. Weird timing, and that weird timing is because serpentine is ancient, say 3.8 billion years old, but reports on methane gas are contemporary. And why is that? Maybe fractures deep underground could be providing necessary water and heat for serpentine to be formed today. Okay, sick. Happy landings. Regardless, would like to see the region with its evidence for hydrothermal activity to be put back on the shortlist for landing sites. NF was on an earlier list of potential landing sites, but was cut. Matthew Golombek of JPL notes that Nili Fossae region is large, and the reported sites of carbonate and serpentine are far apart. Furthermore, the evidence for methane suggests a large generalized plume that cannot be assigned to a specific spot at all. All of these things are not available in one landing. Ellipse, says Gulenbeck, who was co-chair of the landing site committee for the rover. He says that NF was removed from the list mostly because of the landing concerns. Nice. I love to hear it. That's the stuff I want to hear. Like, why was this place not picked? We got it. Okay, so large methane plume cannot be assigned a specific spot at all. I see what's happening is they're like averaging all the smaller plumes together into one big plume. We're remote. And also reported sites of I double of never double of carbonate and serpentine are far apart. Okay, dope. I need to look up Bethany Element a bit more because she seems to really like Nili Fossae. What you been up to recently? Okay, bit of a baller. Oh, she's a professor at Caltech. Okay. I'll give her a follow. Okay. Okay, so that's this paper done with, right? Oh no, I didn't properly read through this, I don't think. Oh no, I did. Yeah, about this guy saying why we can't use that place. Let's move on. Okay, so new article. As the crust sagged under the weight of lava flows. Isides. Okay. And Isides is that big fuck off crater with the volcanoes near enough to Nili Fossae. Alright. One thing I'm getting here is how Nili Fossae isn't the best place to land. So that's a big argument as to why a balloon is good for here, because you're not going to land the balloon. So what I want to say is argument that NF is ideal for balloon exploration, as it is a tough place to land. We've seen this mentioned already, but and I never really looked into the acidity. Um, what's it saying here? Water probably not too acidic. Um, relatively neutral acidity would have favored conditions for life. Okay, we're getting there, boys. We're getting there. Okay, so this is from 2015. Oh, quite recent. I'll definitely be making notes on this. Article. Mysteries in Nili Fossae. And it's Astro. Wow. Excuse me. Did I read this already? This sentence is like a copy and paste of what I read earlier on. Maybe this is a different paper though. Okay, next paper, baby. Ooh. Alright, we're gonna on to the big stuff. Methane seepage on Mars, where to look and why. Dorothy Z. Euler, Jeeves, Ethiop. Okay, I need to take a break before this paper because it seems like a bit dense. So I might go make myself a cup of tea and then come back to it. I think we'll go for 2 tea breaks in this session. I'm gonna go for a tea break now, and read this paper. And then later on, we go for another tea break, and we might watch some videos. So yeah, quick tea break. Alright, boys. Be right back. Oh baby, there's still some coffee. There's still some coffee in the jug, so I'm just gonna get some coffee.
Our Perseverance rover takes up residence on Mars, the space station's next commercial resupply mission, and a new date for a commercial crew test flight. A few of the stories to tell you about this week at NASA.
The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
On February 18th, our Mars 2020 Perseverance rover mission safely touched down on Mars.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
The rover landed in Jezero Crater, a region targeted for the excellent opportunity it presents to accomplish the rover's primary goal of finding signs of past microbial life. Within minutes, the rover's first images from Mars reached Earth, confirming Perseverance was A-OK. And even more images followed, including amazing views of the rover's descent captured by our Mars Reconnaissance Orbiter, and stunning views from onboard the lander showing how descent appeared from the rover's point of view.
You have to somehow believe that you can do it, or else you'd never try to put a car on the surface of Mars, right? It's crazy. But there really is no good way to describe that moment when it's over and you hear those words, touchdown confirmed.
This is the most advanced NASA rover to make the nearly 300 million mile trip to Mars. It's loaded with groundbreaking technology to help pave the way for future human exploration of the red planet. This includes the ability to collect and leave cached samples of Martian rock and regolith that a future mission being planned by NASA and the European Space Agency could retrieve and bring back to Earth for study.
This mission is amazing on its own. Science, technology, and caching samples to bring back to Earth, but it's also part of our bigger exploration plans, right? Which involve preparing for eventual human missions to Mars.
While Perseverance works to characterize the region's geology and past climate, there are also plans for the Ingenuity experimental helicopter to make the first controlled flight on another planet. Having a flying robotic explorer could be a huge benefit for a human mission on Mars.
Being able to fly will enable us to get to places that we cannot get to with rovers and astronauts, like sites of steep cliffs, deep inside crevices, areas of high scientific interest. It will be game-changing.
Perseverance will undergo several weeks of testing before it begins its 2-year science investigation of Mars. The February 20th liftoff of Northrop Grumman's Antares rocket and Cygnus spacecraft from our Wallops Flight Facility marked the start of the company's 15th resupply mission to the International Space Station for NASA. The Cygnus, named after late NASA mathematician Katherine Johnson, is loaded with about 8,000 pounds of scientific research, crew supplies, and hardware for the station crew. An uncrewed Russian Progress supply ship arrived at the space station early Wednesday after launching from Kazakhstan on February 14th with just over a ton of nitrogen, water, and propellant. The Progress will be used to detach a Russian docking module later this year to prepare for the arrival of a new multi-purpose laboratory module. NASA and Boeing are now targeting no earlier than Friday, April 2nd for the launch of Orbital Flight Test 2, or OFT-2, the
I'm at the Jet Propulsion Laboratory in Pasadena, and I'm here to see the first drone that's gonna fly on another planet. It's the Mars helicopter. Come on.
So, this is our baby.
No way.
Yeah.
That thing right there is the actual machine that is going to take off and land on Mars. It's going with the Mars 2020 mission. That is the Mars helicopter.
This will be the first powered flight in another planet.
I mean, this is that. Now, it's necessary to say first powered flight because in 1985, the Soviet Vega missions deployed 2 helium balloons on Venus. They transmitted data for over 46 hours while floating at an altitude of 54 kilometers in Venus's dense atmosphere, which at the surface has a pressure of over 90 Earth atmospheres. In contrast, Mars has very little atmosphere, only around 1% of Earth's.
Flying this kind of helicopter is equivalent to flying a similar helicopter on Earth at 100,000 feet. So you don't hear about many helicopters at 100,000. I think 40,000 feet is probably the record.
I checked. 40,000 feet is the record altitude reached by helicopters on Earth. 85,000 feet is the highest a plane has ever flown. On Mars, the air is even thinner than that.
right? In terms of density, is 1% of what you have in this room. So in this room, a cubic meter of air is about a kilogram.
Yeah.
The same cubic meter on Mars will be about 15 grams to 18 grams. So that
so you have to push a lot of air down.
Yes, you gotta get a lot of air flowing. And so the obvious trick, if you will, is to spin the blades faster.
It can spin between 2,300 RPM and 2,900 RPM.
That is fast.
That is fast, yes.
2,300. Here I'm trying to work out exactly how fast that is. So I looked it up, and on Earth, helicopters typically spin their rotors at around 500 RPM. So the Mars helicopter will have to spin its blades 5 times faster.
But there are some limits. You know, we really don't want to get the tips of the blades breaking the speed of sound.
Because then you have shockwaves and all.
And you get all kinds of funky aerodynamics and transonic flows and things like that. So you don't want to go there. So we, in our designs, keep the tip mark numbers down to below about 0.7.
So 70% the speed of sound.
Yeah, so it's very conservative.
One advantage of flying on Mars is that gravity is only 38% of what it is on Earth. Even so, making the craft lightweight was essential.
Keeping the mass of this vehicle contained during the entire design process has been the major challenge.
Every single part had to be considered. The entire vehicle is less than 1.8 kilograms.
Whoa.
So less than 4 pounds.
That's about the same as this laptop.
The blades are foam core with carbon fiber layup. Each of them is about 35 grams.
Wow.
Yes, it's quite light. Yes.
35 grams is the mass of 6 quarters. Think about that. 2 35-gram blades lifting an 1,800-gram helicopter by spinning 40 times per second in just 1% of Earth's atmosphere. How long can it fly for?
It's designed to fly up to 90 seconds.
A minute and a half of flight.
Yes.
To me, that sounds like forever. When you're talking about another planet flying autonomously by itself in 1/100th Earth's atmosphere, I mean, come on. Like, that's a long time.
It is, yeah.
One of the questions I had was, why didn't they use a quadcopter design? Well, because on Mars, the blades have to be so long that the whole craft would barely fit on the rover. 2 counter-rotating propellers provide the simplest design. They also generate lift more efficiently when stacked on top of each other.
The bottom rotor sees the sort of the more compactified flow. The top one pulls it, the bottom one sees sort of a more concentrated flow. Right. So the bottom rotor actually can do better than if they were separated apart.
But how do you test a helicopter designed for conditions on Mars on Earth? What would happen if you just took your Mars helicopter and you tried to take off on Earth?
It would just make a lot of noise.
Really?
And it probably wouldn't get to full head speed either.
Because of how much atmosphere we've got.
Exactly. It's like trying to swim in a thick soup. We have a really amazing chamber here on lab called the 25-foot space simulator. And in that chamber, you could simulate any kind of atmosphere you want. You can go to Martian pressures, you can stay at Earth pressures, whatever you want. But that only took care of half of the problem. That was the aerodynamics aspect of it. There's the other part, which is the gravity. We needed a way to fake Mars gravity here on Earth, and the best way that we could figure out to do that was a gravity offload. Gravity
offload just means pulling up on the helicopter, so it only has to support about 38% of its weight, just like it will have to do on Mars.
And effectively, it was a high-tech fishing reel. So taking a brush DC motor, a reaction torque sensor, and a pulley, mounting that a couple stories in the air, and then attaching a fishing string to the top of the helicopter that would tug the necessary force required to offload the differences in gravity.
An actual fishing line?
Yeah, real fishing line.
But isn't that stretchy? Like, don't you want something that's perfectly rigid so as soon as you apply the torque, it gets applied to the craft?
Right. And we did a lot of testing with different vendors to find out which fishing line had the best spring constant for us.
What does the helicopter sound like? I imagined that in 1% of Earth's atmosphere, the helicopter would be pretty quiet.
Yeah, you're still at 1%, but it's still real loud.
Really?
Yeah, we have audio recordings of it too. But it's I would characterize it more like something like that. When the gravity offload system was working and the chamber was pumped down, the helicopter thought it was on top. It felt.
How do you actually steer this thing around and drive it?
So the way helicopters work is they have something called collective and cyclic. So what collectives do is they change the pitch on the blades uniformly. So throughout the entire revolution, if you move the collective, the blades will change their angle of attack, you'll get more lift. So that's basically what you would provide you heave control, right? You pitch more, you go up, pitch less, you come down. But
the angle of attack is the angle that the wind flow makes with the rotor. So if you imagine like the particles of air hitting the helicopter rotor, the angle that makes as it impacts the rotor, that's the angle of attack.
Then there's something called a cyclic on helicopters, which basically what it does is it modulates the pitch as it goes around. So it can pitch a little bit more here, less here. So it kind of like modulates.
Pretty controlled.
So what that does is it provides an asymmetric torque, right? When you're pitched up there, you get that additional torque. Now you get it, depending upon the stiffness of the system, you actually get it with that gyroscopic lag that can happen afterwards. So once you get an asymmetric torque, the vehicle wants to start pitching or rolling, right? So once it pitches and rolls, you're doing it stably, you are now pointed in a direction, and your thrust vector now has a component that's horizontal in the direction that you pitched, right? So then you start translating in that direction.
I've heard that initially someone tried to fly it with a joystick.
Yes.
An early prototype.
If you were sitting right there on Mars and you were trying to joystick it, what is it like? And it's almost unflyable. And the reason for that, it's the aerodynamics of when you want to command a roll to the left, because you see yourself starting to move to the right, and you start commanding a roll.
Yeah, the way you move is so different.
So that delay effect makes it very, very difficult for a human to try and pilot it.
You can't fly this from Earth.
Because of the 20-minute kind of time delay, so you have to really send sequences.
So essentially, you're going to push a button, and like 20 minutes later, it'll take off and do its thing, and then you'll find out.
The way this flies autonomously, it has onboard gyros, onboard accelerometers, and onboard camera, and altimeter, and an inclinometer. And so using that sensor suite, real-time measurement, against the terrain, and of course the gyros and the accelerometers sensing on board, the real-time estimation of the state of the vehicle is made continuously, again, hundreds of hertz. And then that's fed into the closed-loop control algorithm that takes the estimated state and then generates
very complex
that's needed at the blade level, and then the blades are continuously being controlled. So when you see video tapes of our successful flights, right, and the vehicle looks dead calm, is coming up and hovering and going laterally, coming back, the machines are working very, very fast and very, very hard. It just looks very calm, but yeah, so the blades are being continuously controlled.
That is amazing.
Yeah.
How will it handle a gentle breeze?
Same.
A lot of the movies depict
dust storms.
depict dust storms as being very aggressive on Mars. The truth of the matter is that 1% Earth's atmosphere is very little matter actually hitting you.
I mean, you're using that to lift yourself.
Exactly.
So obviously,
so there's enough to lift, right? But we also need to spin at 2,200 RPMs to be in the ballpark of lifting ourselves.
We built our own wind tunnel that we put inside this 25-foot chamber. How many fans was it, Teddy? 960 computer fans. So, but it did sound like a jet engine taking off. So we built a fan wall array. It's called an open cross-section wind tunnel, where you don't need the walls. Just the fact of having batteries with our electronics board, so the electronics boards also stay warm.
To be integrated onto the rover. Okay, so usually you won't be seeing that. So the center of the cube is the ring of batteries. Okay, there is space between the battery and the circuit boards that you're seeing, and then there will be a shell that we put on called a fuselage shell, and that will close like CO2, the gas around. And so the enclosure itself, we're using the CO2 gas as the insulation material.
oh wow, no aerogel.
No aerogel. We did consider it was in the game. It was in the consideration in the beginning, and it turns out that just the CO2 as insulator itself was sufficient for us to close if we have a choice.
Wait.
Yeah, there you go. You're welcome to our team. If we have a choice.
Wait.
There you go. You're welcome to our team.
Now, before the helicopter can experience the aircraft, it's also a spacecraft.
It has to survive launch. It has to survive launch loads, which, easily exceed about 80 G. Because the vibrational loads are 80 G.
Sphere, the helicopter needs to be and put you down somewhere.
For example, the very last thing that
I'm disconnected there for a few minutes.
You blow it up. Basically, it's the materials undergoes a phase transition, which certainly increases the stress in.
Then once we're on the surface, the rover drives over us, It gets about 100 meters away, and then we have about a 2-hour counter internally where we'll wake up after 2 hours, wait to hear some RF transmissions, and if we do get that link with the rover, then great.
Our base station on the rover would issue the fly now command. First flight will probably be a mutual selfie, you would think. This is, after all, the selfie age. So
I like that as the goal of the first flight.
Yes, it is. In fact, the best time to fly this is at 11 o'clock in the morning local time on Mars. And the reason for that is we would have come out of the night where we would have spent a lot of battery power trying to stay warm by leveling the whole craft to the ground. Also, 11 o'clock is where the sun would have warmed up things, so we don't quite have to heat up as much. And also, it's not late afternoon where, because of the warmth, the density has begun to drop, okay, and the winds have begun to pick up. Now, what we will investigate is, after we get the first couple of flights under our belt, I'm sure we will try to fly in the afternoon and do more exploratory things. But the most conservative thing we can do is to sort of pick a mid-morning flight.
So what is the purpose of this mission? The Mars helicopter is first and foremost a technology demonstration to prove that we can fly on another planet. The helicopter can take color photos and videos, but its purpose is not to make scientific discoveries. Instead, it is to help engineers figure out how to design and build aircraft for future missions.
You can imagine something that's about 30 kilograms carrying, a 2-kilogram science payload, doing exploration, acting like a scout, like a small vehicle like this, scouting ahead for some future rover, or it could be a gadget that goes, or it could be a completely standalone craft, sides of cliffs and so forth. So the real emphasis here is to try to get back all the engineering data so that it can inform that future design.
Flying on other planets will provide a new dimension in space exploration. An aircraft is faster and capable of covering more ground than a rover, and it can provide higher resolution imagery than an orbiting spacecraft. So maybe one day aircraft will be the companions of future rovers or even astronauts exploring other worlds.
Pretty dope. I'm gonna give this guy a sub. Hmm.